Okay, so we have questions 3 and 5 this week.
Yeah, the fun stuff. All right. So it says, what is meant by mosaic pleiotropy? So I just kind of wrote, often there is a trait that is coded for by numerous genes rather than one sole gene locus. So you have numerous genes coding for one trait, and one gene can be activated while another is not. They also vary in function and activity based on the type of cell and its location in the body. So basically, you have all these genes that are coding for one specific trait, and in certain locations of the body, you're going to have one of these genes expressed more frequently than the other, kind of that way. So
I thought it was that, like, you have one gene and it's expressing a variety of proteins.
oh, maybe I have mine the opposite.
Yeah, I thought that's what it was.
What's that one with the I thought pleiotropy was that. There's another one that's that then. Okay.
So the text said that, like, the same gene functions in different times in different places during development. So it's like a way to conserve energy because you're only having one gene and it's being expressed in so many different ways, without needing to be duplicated, so that you could, like, I don't know, differentiate your human body or whatever species you're.
That makes sense.
Cool. Okay, and so the number 5 says, explain modularity of cis-regulatory elements. So I put the series help modulate gene function by controlling when and where toolkit proteins are expressed in development, and they're tolerant to mutations so that they can continue to regulate these proteins without being really affected by things, by any, like, arising mutations. And then they're also able to expand gene function. So it's really maximizing the expression of these proteins without needing to duplicate, which is necessary because duplication can be detrimental at the wrong times.
Yeah, that's pretty much what I said too. Yeah, so it's just in just an evolutionary advantage because you can regulate genes instead of having to, I don't know, turn off a whole entire gene sequence and expend all that energy in order to do that. So it's just an easier way to regulate.
It's so energetically favorable. So.
Yeah.